Okay. So this video is intended to solve or show you how to do a few things using AutoSCAD and FreeCAD. So let's assume that you have done in OpenSCAD, you've made some sort of part or set of parts. In this case, it is a rack meant to hold solid phase extraction tubes, and is designed to be cut from a 1/4 inch thick sheet of plastic. In this case, we use Teflon for chemical resistance. And so I've designed it in OpenSCAD with all of its various properties. But now I actually need to lay it flat and arrange the parts on a flat plane whose dimensions are equivalent to the slab of Teflon, my stock, with which it will be cut. And so we're going to do that now. So we have this SPE rack, and we will simply want to export it as an STL file. We've already done that. But we can overwrite it. So at that point, assuming you have these assembled, these full assemblies already saved as STL files, we simply go into FreeCAD. And the first thing we want to do is open one of those objects. Well, I suppose the first thing that we'd like to do is we have FreeCAD. The only non-standard add-on I'm using is A2+, which you'll need to install from the add-on manager, and you'll search for A2+, and install that. Everything else, all these other workbenches within FreeCAD are default workbenches. So the first thing we'd like to do is go into Sketcher. Now the first thing we should do is import one of our STL files, which we'll do now. And so we will import the one we just saved, which is SLE rack for lignin. You see it imports it, we can rotate it around, and we can see we have our nice rack imported. Unfortunately, it's imported as a mesh when you open an STL file. So we'll need to go to Arch. Well, first let's make our stock plane before we manipulate this too much further. So go to the Sketcher workbook, and we'll hit Create New Sketch, and we'll use the parts XY plane. So you can see X and Y, so we want it to be on the flat surface. These can be reoriented later on, but this will set us in that. And so then we will simply make a rectangle. It's easiest if we start from origin, from the default origin. So we start from the default origin, hold down Control, click, when we have the origin selected. Very tricky to use. Okay, try one more time. New XY plane. So if we hit this View Selection button, it will just show us the plane that we're on. So it'd be easier to select everything. Middle click to pan around. All right, so then hold down Control. Unbelievable. Okay, one more time. XY plane. Let's make it all visible. We want to make a rectangle. We would like to start from the origin. Okay, so we've made a rectangle. It has a series of constraints that constrain what it is. We need to add just a few constraints. So one is the vertical distance. These are all in millimeters. So STL files, like they're unitless, but they imported one unitless unit of an STL file gets imported as a 1-to-1 millimeter. In the case of what we've been working on, the rack in there is all defined in inches in terms of drawings. So for the purposes of this, I'll just consider 1 millimeter to be 1 inch. Obviously, at some point, this will get exported, and we'll simply need to define the scale later on. So we're going to do 12 by 24, and that's it. We have that nice sketch. We'll go to our sketch, and we'll go to Part, and Extrude. No, we should go to Part Design and select Pad. This button here. Create a new body. All right, the sketch needs to be in the body. Unbelievable. Okay. Welcome to FreeCAD. Oh, fuck me. All right. All right. this video, we are going to take a series of parts that we've designed in AutoSCAD and import them into FreeCAD and then arrange them on a flat plane so that they can then be prepared for tool paths for cutting out of stock to make individual parts that can be assembled into our assembly. So we're going to be working with two different AutoSCAD parts for the moment. So one is this file rack, which is going to be placed underneath this SPE rack, allowing us to do supported liquid extraction when we're cleaning up our samples. So what we want to do is export those as STL files. I have already done that, but we'll do it again. There's that. It's the vial rack. Save that as 8mm vial rack, STL. All right, so then we're done with AutoSCAD. We'll come on over to FreeCAD, open it up. We can start from scratch. The first thing we're going to want to do is go ahead and go to Part Design, create new body, and then go to Sketcher, create a sketch. It says no. All right, first thing we're going to do. All right. Okay, so in this video, we are going to go through the steps needed to take some models we've made in AutoSCAD, such as these two here, import them into FreeCAD, and then lay their parts flat so that they can then be milled out of a sheet of stock, so that they can then have our individual parts that we'll then assemble by hand. So we would take both of these and export them as STL files. I've already done that, but we can do it again. So render this, export as STL, 8mm vial rack. Excellent. Go into FreeCAD. So in FreeCAD, the only non-standard workbench I'll be using is A2+. So we're going to FreeCAD, make a new, and then we're going to go ahead and import one of those two objects. For now, we will simply import the SLE rack. Excellent. So then we'll want to go to Part Design and select Create Body. And then within Body, go into Sketch, create a new sketch on the XY plane. If we select this View selection, we go into Section View, and now we're just seeing the base. We've gotten rid of the third dimension on top. So what we're going to want to do is make a rectangle. And we want to select the origin. Any two dimensions is fine. FreeCAD works by default in millimeters. I designed the AutoSCAD files in inches. So it just simply imports, STL files are unitless, so 1 unit of that I was thinking of as inches. In this, it'll be millimeters. It won't matter because in the end, we'll simply define the size in the respective pathmaking program for whatever CNC device ends up being used to actually mill this. So the main things we need to do is we've made our surface. Then we simply want to define the width, which will be 24 inches, and define the height, which is right here, which will be 12 millimeters or 12 inches in this situation. Excellent. And then we have that. We'll want to go to Part Design and select Pad. All right, I guess we need to put the sketch in the body, since we want that to become our pad. Now, our pad is just going to extrude it. We want to use the thickness of our material, which happens to be 0.25 inches. Again, millimeters or inches in this scenario. So now we have the stock that we are going to actually end up having. So that's great. We can go ahead and rename that to stock. Then we can go back to the imported rack. Right now it's a mesh. We'll need to go into Arch, and under Arch, go to Split Mesh. So now we have all these various parts. It's important to note that this top rack, which we'll go ahead and rename to upper rack. This lower rack, which we'll rename to lower rack. So those are unique. The upright and the base frame are mirror images of one another, so we only need to save one of those. So rename that to upright. Rename that to base. The second upright and the second base we can delete for now. So we have these as individual meshes. We'll go back to Arch, go back to Utilities, and go to Mesh to Shape. And we'll then convert those into solid shapes. Excellent. These got renamed again. I'm going to rename them one more time, just for sanity. Base, upright, upper, lower. Excellent. All right, and then these don't need to be grouped. Don't delete its content. All right, so then we have all of the parts needed for this particular setup. Before we start adjusting things, everything needs to be saved as an individual part and then imported as individual parts, which is simply how, so A2 Plus is software for assembling parts, so they need to be stored as individual files. That's simply how it prefers to work. There are some benefits to that, but regardless, that's simply how it works. So for each of these parts, starting with the stock, we'll go to Stock, Export. We'll make a new folder called SLE Rack, and well, I suppose the stock will be useful for a variety of things. We'll say 24 by 12 by 0.25 inch stock. And then the actual parts, we'll do the same thing. Export those, and for those we'll put them in the SLE Rack folder. And that'll be base, upright. I'm going to go ahead and don't show this again. upper, and lower. Excellent. Since we know we're going to be working with it, let's go ahead and do the same exact thing just once. We don't need to make the stock again for the actual vial rack. Once again, a vial rack. We're in arch, split mesh, select the mesh, mesh to shape. Bunch of shapes. Same deal as before. Upper and lower are unique. The two sides are mirrors of one another. We only need to save one of those. So we will export the upper. And that will be upper. Lower. Upright. Okay. So let's save this unnamed thing in a main folder. We'll call it assembly1 with today's date. And then we'll go into A2+, and we have to use add part from external file. And we will start with our stock. We'll go into the rack, 1 base, 2 base, lower, upper, upright, and the upright again. At this point, I think it's useful to rename these. Further, it's useful to group these just for our own organization, and we'll call this our SLE rack. So then let's go ahead and continue and upload our file rack. Right now everything is sort of on top of each other. We can sort that out in a minute. Same as before. Let's group these. And this is the file rack. File, upright 1. Okay. So now we have a ton of parts. So we can see everything as we go. I like to change the appearance of the stock and give it a bunch of transparency. And then the stock itself needs to have a fixed position. Everything else should not have a fixed position. And the reason that stock has a fixed position is because I started it from the origin. If I hadn't, it wouldn't have a fixed position, but it does at the moment. Or it might be some other reason, I'm not quite sure. Regardless, it needs to have a fixed position. You need to set it to true if it's not true, otherwise this stuff won't like it. So if we go ahead and start, we can hold down Control. Uh-oh. All right. I think everything is there. It's just kind of jumbled at the moment. We could start moving some of this out of the way. So we could transform and we're going to want to hold down Shift and the axis we'd like to move them. All right, now everything's out of the way. Unselect everything. So that's a ton of parts. Now we're actually going to start using A2+. So let's go ahead and click the surface and the surface and add plane coincident constraint, which will cause those two planes to now be, well, both parallel and at the same on the same line, coincident. We'll hit accept. So now we can see that moved that surface all the way down. The next thing we want to do is take one surface of that, like this, and we would like to add another one. What is going on there?